Okay, today's objective is students will be able to factor polynomials using the grouping method. Okay, get that down. Alright, let's remember what it means to factor. Think in your head right now, what does it mean to factor? Okay. Factoring simply means taking something and writing it as the product of two different things. So like if we factor 10, we could rewrite that as 2 times 5, right? It's the product of two of its factors, basically. Okay. So far, to factor, we've learned one method. The one method that we've learned so far is to factor using the GCF. Okay. Today, the other method that we're going to learn is the grouping method. Okay, so far we'll have two different ways to factor. And we're actually going to use the GCF today as well, but we're going to add to it and also learn how to factor using the grouping method. Okay. Alright, so let's get right into. Okay, so example 1. Let's say I give you something that says factor, and the polynomial that it gives you is 4ab plus 8b plus 3a plus 6. Okay. I do want to give you the steps to start this off, so you should have some room off to the side. In fact, I'm going to create a new slide. You guys should have some room off to the side. If you don't, you can just do it. But I want to give you the steps, and then we'll use these steps, and I'm going to have to do them on another page because of space. But step 1 is going to be to group. Let's actually, let's label this, give it a heading of steps. Okay, step 1 is to group terms with common factors. Okay, we're going to group terms with common factors. Okay, step 2 is going to be to find the GCF of each binomial. And that's a step that you'll see that we've already actually done. You should know how to do that. Okay. Step 3 is going to be to factor out GCF. So once you find the GCF, you got to factor out the GCF, and we know that we do that. We basically divide out. We divide out the GCF. Okay. Step 4 that we're going to do is we're going to put GCF outside of parentheses. Again, basically as steps 2, 3, and 4 we already did. Okay, we did that in the previous objective. And then we're going to put what is left, I'm going to put what is left inside the parentheses. Okay. Finally, step 5, what we're going to do is we're going to put GCFs together in binomial. Okay. And what we're going to do is just rewrite we are just going to rewrite other binomial. And I do want us to write a note that it should be same. Okay. Give you go ahead and hit pause if you're not done with these. I know steps like this, when I just give them to you, are like, oh boy, what are all these steps? But you'll see now with the example problems, and if we follow these steps, they'll make perfect sense. And luckily, we've already done most of these steps, so there's not a whole lot new. Okay? So let's go back to our slide number 3, our example. Okay, so here's the problem. The first thing that you should always do with these is look and see if there's a GCF of the entire thing. So if we look at 4, 8, 3, and 6, is there a greatest common factor of all 4 of those numbers? And the answer is no. I mean, if you look at 3, okay, 3 is a prime number. So unless 3 goes into the 4, the 8, and the 6, then there's not going to be anything to factor out. And the 3 does not go evenly into 4, so we know that we can't factor out any number. And then we should look, well, do they have any variables in common? And the answer is clearly no, because the 6 over here at the very end doesn't have any variables with it. So we can't factor out any variables. So again, first thing is look and see if there's a GCF that you can factor out of everything. Okay? Because there's not, we're going to go to the grouping method. The grouping method just shows that we can oftentimes group these into 2 binomials. Okay? So if we look at this, and I do want you to put this key point here, that we're going to keep the sign inside. Okay, it's almost like, you know, when we were dividing the like terms, we put the bars before the addition or subtraction sign. Same thing. That positive, that plus, has to stay with the 3a. Okay. Now, step 2 is we need to find the GCF of each of these binomials. So by doing these parentheses, we now created binomials that we can find the GCF. So what is the GCF of 4ab and 8b? Well, the GCF of the numbers of 4 and 8, the GCF of those would be 4. Okay, and what I'm going to do with my GCFs, okay, what I'm going to do with my GCFs is actually put them down here, because if you show this work, it's going to really help you avoid a very, very common mistake. Okay, so I know that 4 is a GCF. Now, do they have any variables in common? And the answer is yes. They both have a b. So I could also factor out a b. Okay, so my GCF is 4b. So I'm going to factor out of each of these terms a 4b. Okay, so then I have 4 divided by 4 is 1, or it just cancels. B over b basically cancels. Okay, and what's left is just my a. Okay, now in this one, 8 divided by 4 is 2, and it's a positive, so I'm going to write plus. Okay, and then b over b cancels. So what I'm left with, when I factor out my GCF of this first binomial, what I am left with is 4a plus 2. Okay, now I got to find the GCF of this second binomial. Well, what's the GCF of the numbers? Well, of a 3 and a 6, the GCF that we should see right away is a 3. Okay. Now, do they have any variables in common? Well, this one has an a, but this one doesn't. So I can't factor out any variables. So my GCF is just a 3. Okay, so now I'm going to factor out the 3 and see what's left. Again, this is stuff that we did in the last objective. We're factoring out a GCF. Okay, 3 over 3 cancels. What's left? A. And then 6 divided by 3. A positive 6 divided by 3 is a positive 2. Okay, so that's what's left. Okay, so that was step 3. We factored out the GCF. Okay, now step number 4 tells us to put the GCF outside of parentheses, which we did right here, and put what's left inside. We also did that right here. We put what's left inside parentheses. So we're done with step 4 too. Okay, so all we have to do is step 5 basically. And if you look at something here, what do you notice about these two things? What do you notice about these two things? Well, they are the exact same. And they have to be for the grouping method. Okay, they have to be for the grouping method. If not, something is wrong. Okay, so all we have to do now is what I like to call basically just hug our GCFs. So our 4b and our positive 3, okay, we're going to bring together, and they're going to hug or come together in one binomial. So it's a 4b and it's a positive 3. So I have 4b plus 3. And then my other binomial is what I have right here, the exact same thing, right? What's left? The a plus 2. Okay. What we did, remember, keep in mind what factoring is. Factoring is taking one thing, this whole expression up here, and you guys don't need to write this, okay? Don't circle yours. I'm just showing you. We took this whole expression, or polynomial, and we rewrote it as the product of two different things. That's what factoring is. Now, here's what's awesome. We can check to make sure that we got it correct. Okay, how do you think we can check to make sure that we got this correct? I want you thinking about that for a few seconds. How can we check to make sure that we have this correct? Okay, hopefully you said that we can just multiply these. And how do we multiply these? We use a box method. So let's check it real quick. So our check, we can multiply. So I said that my answer was a 4b and a positive 3, and then it was also an a and a positive 2. Okay, so if I multiply these, 4 times, let's see, 4b times a would be 4ab. 3 times a would be 3a. 4b times 2 would be 8b. And then 3 times 2 would be 6. Okay. Do I have any like terms in this? And the answer is no, there are no like terms. So if I rewrote it, I would rewrite it as 4ab plus 3a plus 8b. And I put the a before the b because it comes first in the alphabet, and they both have a power of 1. And then plus 6. And the question is this the same thing with what we started with? And the answer is yes. You may say, oh, the order of these is different. And remember, with addition, does order matter with addition? And the answer is no. It doesn't matter if we would have put the 8b before the 3a. You know, it's not in the descending order like we learned. But again, with addition, order doesn't matter. So this proves to us that it checks out. Okay, that yes, we did factor it correctly. Now, what would happen if you check your answer and you find out, it doesn't check out to be the same thing that I started with? Then clearly you factored it wrong, and you'd have to go back, check your work, and try refactoring it. Okay, let's do a few more examples. So example 2. Okay, example 2. What if I give you, it'll say to factor 4ab plus 3a plus 8b plus 6. Okay. You notice with this, it's basically the exact same problem as before. Okay. So if we look at this, what if I look for the GCF, don't see one. Okay, so then I'm going to go on to grouping. Okay, what could you factor out of this first part? Well, both of these have an A and an A, right? So could you factor out anything with the 4 and the 3? And the answer is no. You couldn't factor out anything with the 4 and 3. There's not a GCF. So the only GCF of this one is basically a 1a. Okay, so let's factor out a 1a. Factor out a 1a. Okay, what's left when we factor that out? Well, we have 4b, and then we have plus 3 divided by 1 is a positive 3. A over a cancels. So I have that. Okay. Now, let's factor out something of this. So let's look up my numbers. An 8 and a 6. What would be the GCF of an 8 and a 6? And the answer would be, let's see, 2 I think would be the GCF. And then do they have any variables that we could factor out? Well, this one doesn't have a variable. 6 doesn't have a variable, so the answer is no. So we need to factor out a 2. Oops. Sorry, I shouldn't. Let me go back and erase that. I shouldn't put that line in. So I need to factor out a 2 out of each of these. What's left? 8 divided by 2 would be 4. The b is still with it. 6 divided by 2 would be 3. Okay? So then we do the same thing. First of all, are these the exact same? And the answer is yes, they're the exact same. Okay, and then what do we do with our GCFs? Well, we basically hug them. So I would have a and a positive 2, so it's plus 2. Because again, it's plus because this is a positive 2. Okay, and then what's left? The 4b plus 3. What do you notice about this problem? Okay, well, we started off, we grouped different things together, right? But we ended up getting the exact same answer. Okay, we ended up getting the exact same answer. Okay, and that's going to be the case. Okay, if you factor out, it doesn't matter really with grouping. If you factor it out completely, you're going to get the same thing. So I wanted to show you that sometimes we can actually change the order of these two things. So what this says is that we can, let's write this down, can sometimes change order. And that will allow us at sometimes to find common GCFs of things where we wouldn't have been able to otherwise. So let's maybe look at an example where we need to switch things around. Let's look at example 3. Okay. So if it gives us something that says factor, and it gives us 2my plus 7x plus 7m plus 2xy. Okay. First thing that we should always do is what? Well, I hope you're saying we should always look for a greatest common factor of all of these terms. So if we look at the GCF of the numbers, 2 and 7, there's not a GCF of the numbers because 2 doesn't go into 7 and they're both prime. So then we have to look at the variables. Do they each have an m? And the answer is no. This one right here doesn't have an m, right? Do they each have a y? No, they don't each have a y. Do they each have an x? No. So there's nothing common to all 4 terms. So then we would ask ourselves, well, if I group these, and I don't want you to do this, actually go ahead and do this. So if I group these like this, okay, is there anything common to 2my and 7x? Is there a GCF of those? The answer is no. The GCF is only 1. Okay, there's no common factor other than 1, and there's no common variable. Okay, so that's a problem. And I'm sitting here like scratching my head. Well, what can we do then? Okay, if we look at it, okay, you should kind of notice something, that this one has an m and this one has an m. Right? This has an x and this has an x. Okay, so maybe they just gave us a problem where it wasn't arranged in the best way to start off with, but if we rearrange it, then we could figure out some common factors. Okay, so all we need to do is we just need to rearrange. So let's write this in words. We need to change order. So we can have a common, oops, that's ugly. So we can have a common factor. Okay, so let's change the order. It would make more sense to write 2my, and then the m's, it would make sense to put the m's together, right? And it would make sense to put the x's together. So I'm going to write 2my plus 7m, and then I'm going to write that plus 7x, and then plus the 2xy. Okay. Now if I group these, and again, everything should be in groups. Now if I group them, I have a common factor here of m. So my common factor for this would be m. So if I factor out an m of each one of these, okay, so 2, that's a 1m basically. 2 divided by 1 would be 2. M's cancel, leaving me with 2y. And then plus the m's cancel, leaving me with just 7. Okay, what's the common factor of these? Well, it's just an x. So I need to divide both of these by just a 1x, or just factor out that x. So write that out here. When I factor that out, the x's cancel, leaving me with 7. And then the x's cancel, leaving me with a positive 2y. Okay. Now we need to check and see if these are the same. Okay. Now, we got to look at these carefully, right? Because it looks like the order changed. This one's 2y plus 7, and this one is 7 plus 2y. So the question is, well, are these the same? And the answer is yes, they are still the exact same because they still have the same signs. Okay, I want you guys to write that as a key point here, that these two are still the exact same. And I'm not going to write it. Okay, you guys can write it in your own words. They're still the exact same because they have the same signs. Okay, and with addition, order doesn't matter. Again, you guys are writing the key point that they are still the exact same because they have the same signs. This is a positive 2y. This is a positive 2y. This is a positive 7. This is a positive 7. So they have the exact same signs, and the order doesn't matter with addition. Okay? So the answer to that one, okay, you would hug your GCF. So what were the GCFs that we pulled out of each one? Well, we had an m and an x. So it would be 1m plus, because it was a positive x, 1x. And then here's where you do need to write that. I would just write it in the correct descending order, where I would put my 2y first and then my plus 7. Okay? And that's your answer. That is your answer for this one. These were your GCFs, and again, you don't have to write this. These were your GCFs, and that was that one that was the exact same that we just keep. Okay? Now, again, you should check this. Takes a couple seconds to check. Okay, so we had an m and an x. We had a 2y and a 7. Okay, oops, sorry, that got really, really ugly. If I multiply these, 2y times m would be 2my. Again, put those in alphabetical order. M comes before y. 2y times x would be 2xy. Again, put them in alphabetical order. 7 times m would be 7m. 7 times x would be 7x. Okay, and then you could just rewrite it where you have your 2my plus 2xy plus 7m plus 7x. And as long as they have the same signs, like if you look at that original problem, it had a positive 7x, it had a positive 7m, it had a positive 2xy, it had a positive 2my. As long as the signs are the same, and the coefficients are obviously have to be the same, it checks out. Okay, that gets us back to our original problem. Okay, if you have questions, make sure you hit pause and write down specifically where you have questions. Okay, let's do, I think, one more example. So example, I think this is example 4. Okay, if it says to factor something like 35x minus 5xy plus 3y minus 21. Okay. Again, the very first thing that we should do is look and see, is there a common factor to all 4 of these terms? Okay, and start with the lowest number here. Does 3 go into all of these terms? And the answer is no. 3 doesn't go into 35, it doesn't go into 5, it does go into 21, but it has to go into all of them. Do they share a common variable, all 4 terms? The answer is no. So then we have to look and say, okay, well, let's see if we can start grouping. Right away, I see that the 35x minus the 5xy, I can see a common factor to both of those. So I'm going to try grouping this to start off. Again, if you can see a common factor, then try grouping them just in the order that it's in and without changing the order around at all. Okay, so what would be the GCF of 35 and 5? And the GCF of 35 and 5 would be 5. If you're still struggling on finding GCFs, okay, you're going to have to do the long work the way we showed you in the previous objective. Okay, and then is there a variable that we have in common? Well, we have the x, so we can factor out an x. Okay, so let's factor that out. Factor out the 5x, factor out the 5x. Again, I already wrote it down here. Okay, 35 divided by 5 is 7. X divided by x cancels. And then negative 5 divided by a positive 5 will get me a negative, so I write minus. Again, this negative 5 divided by positive 5 will give me a negative, so I can write minus. 5 divided by 5 would be 1. X divided by x cancels, so it's just y. Okay. All right, let's look at this next one. Let's see, what's the GCF of a 3 and a 21? Well, the GCF of those would be 3. Can I factor out a variable at all? And the answer is no, because this one doesn't have a y at all. So I need to factor out that 3. Okay, factor out that 3. So what's left is y minus 7. Okay. All right, look at these. Can we just hug them? Okay. You hopefully are seeing something wrong with this. Okay, if you didn't see something, I want you thinking, what's wrong with this right now? Okay, here's what's wrong with it. These are not the exact same. These are not the exact same. Okay, so I want you to write this down, that the signs don't match. Okay, the signs don't match. So what could we do to get it to where the signs match? So essentially I'm saying this is a negative y right here, right? This was minus y. What could we do to get this to be a negative y? And this was a positive 7. What could we do to get this to be a positive 7? Okay. Well, the answer to that is instead of dividing by a positive 3 here, we can instead divide by a negative 3. So we can divide this by negative 3 instead. Okay, so the signs don't match. So let's finish this out. Signs don't match. So instead of dividing by positive 3, divide by negative 3. And that will change our signs. So we cannot forget though, okay, this is no longer a positive 3 right here. We actually factored out a negative 3. Okay, and now when we do that, a positive 3 right here, okay, this positive 3 divided by the negative 3, and you guys don't have to do all the marks that I do, because then your notes will get really sloppy. I have to do that to show you where I'm at in the notes, okay? But you don't have to do all these marks, okay? But a positive 3 divided by negative 3 will get me a negative y. And then negative 21 divided by a negative 3 will get me that positive 7, okay? Now are these the same? Well, this is a positive 7. This is a positive 7. This is a negative y. This is a negative y. So the answer is yes, they are the same now, okay? I'm going to keep my work on this page, so you guys should write your answer below here. But basically, I hug my GCFs, so my 5x and my negative 3 have to hug. So it would be 5x minus 3. Again, it's a negative 3, so we write minus 3. And then I'm going to rewrite it, so my y's first. I would have negative 1y, or just negative y. I'm just going to put the 1 in there. Negative 1y plus 7. Okay? Those are my two binomials. That's my factored form using grouping. So the key on this one, the tricky part, was we actually had to, instead of dividing by a positive 3, we had to notice that our signs were different between these two. And again, you don't have to do this, I'm just showing you. Our signs were different, so instead of dividing by a positive 3, we should have divided by a negative 3. Okay? And then okay, so the check is 5x, and then negative 3, and then we had negative 1y, and a positive 7. Trying to make this box a little neater than the last one. Okay, so a positive 5x times a negative 1y would be negative 5xy. A negative 3 times a negative 1y would be a positive 3y. 5x times 7 would be 35x. Negative 3 times positive 7 would give me negative 21. Okay, and when I write that out, negative 5xy plus 35x plus 3y minus 21. And again, the order may not match up when you write it in descending order, but what you have to do is go and check. In your original problem, did you have a negative 5xy? And the answer is yes, you did. Did you have a positive 35x? And the answer is yes, you did. Did you have a positive 3y? And the answer is yes, we did. Did you have a positive, or I'm sorry, a negative or minus 21? The answer is yes, you did. Okay, so all of those terms check out with the original. Okay, all right. I'm going to put some problems, some worksheet problems on the website. If you cannot open those attachments, you guys actually need to Google and download Adobe Reader. So if you cannot open the worksheet, you need to Google. I would just Google free download of Adobe Reader. And if you do that, you'll see it download on your computer. Okay? Make sure that before you come to class, you have those problems on the worksheet all the way completed, and you have to check your answers. It's insane not to check your answers. So before you come to class, make sure that is done. Okay, I actually want to add one more example because this one's a little bit different. So far I've been saying the first step is always to look and see if there's a common factor to all of the terms in the expression. And so far there hasn't been, but this one there actually is. If we look at the coefficients, the 20, the 8, the 120, and the 48, we should see right away that these are all even numbers. So therefore we know that 2 will go into all of these. It might not be the greatest common factor, but we at least know that 2 will. Okay. Now in my mind I'm also thinking, okay, well maybe 4 will also go into all 4 of these terms as well. So I know that 20 divided by 4 is 5. So I'm wondering right now if 4 is the GCF. Okay, I don't know, I'm wondering. So if I do 20 divided by 4, that'll get me 5. Okay, 8 divided by 4 will get me 2. 120 divided by 4 will get me 30. And 48 divided by 4 will get me 12. So then I have 5, 2, 30, and 12. And there's not a common factor to all four of these because 2 doesn't go into 5. 5 doesn't go into 12. So there's not a common factor to all these. So that tells me that 4 is in fact the greatest common factor to all four of these coefficients. Okay. Now I also want to look at variables. This first term has an A. Do they all have an A? Nope, these last two don't have an A. W, nope, they don't all have a W. K, nope, they don't all have a K. And X, they don't all have an X. Okay, so what I have to do first is I have to factor out a 4. Before I do any grouping, I have to factor out this 4 out of each one of these. Okay, so then I will have 4, 20 divided by, that'd be 5AW squared minus 2AK plus 30XW squared, and then minus 12XK. So again, all I did is I found a GCF and I factored out that 4 right away. Okay. Now what I can do is go back to regular grouping where I can group these. Okay. And once I do that, I'm going to keep this 4 on the outside because one of the most common mistakes with this, and it happens time and time again, is you forget to bring down this 4 through each of your steps. And you have to bring down the 4. You can't forget about it because we're going to have to multiply our answer by that 4 at the end to check it. So then we can factor this. What's the GCF of 5 and 2? Well, there's not one, but there is an A common to both of these. So I'm going to have an A on the outside. So I'm going to factor out an A, factor out an A. So that leaves me with 5W squared minus 2k, and then on this one I can factor out, it looks like, let's see, it looks like 6 would be the GCF of these. So the GCF of 30 and the GCF of 12, 6 is the greatest common factor of those. Okay, and if you're not sure on that, you can kind of use guess and check, or do the factor cows to figure out the GCF of 30 and 12. But I would, always start with your smaller number. 12 doesn't go into 30. So what's the next biggest factor, 12? Well, that's 6. So then see if 6 goes into 30, and it does. And then another common factor is this x. They each have an x. Okay, so then I'm going to divide it out. Again, I'm basically factoring out or pulling out that 6x. So that leaves me with 30 divided by 6 is 5, x over x cancels, 5w squared minus, and then 12 divided by 6 is 2, x's cancel, 2k. Okay. Alright, so my final answer, I need to, again, do the exact same thing. I need to basically pair these together. So I would have a plus 6x. And then I would still have these match up. They're the exact same. That's how I know I did it correctly. So I can just rewrite those. 5w squared minus 2k. Now, if you just leave this as the answer, if you do the box method to check it, okay, and again, don't write this. You guys are just going to watch it. If you do the box method and check this answer right here, okay, you're going to get back to this part of the problem. Okay, again, you guys aren't doing this, I'm just showing you. If you do the box method, you'll get back to this problem. Okay, but was that the original problem? The answer was no. We had to multiply all of that by 4. So that's what I kept saying. We cannot forget, and I want you guys to draw this arrow and draw this 4. We cannot forget, in our final answer, we have to show that we took out this 4. We factored out that 4 from the very beginning, and this would be your final answer. You would have 4, and then the two binomials, a plus 6x, and then 5w squared minus 2k. That would be your answer.